Welcome. I will now show you how to assemble the hardware of the Autopilot. To do this you need to buy a couple of components. I'll provide a list of how to do it. So this is the ISP32. I personally like to use a USB-C variant because I like to move to the USB standard nowadays. This is the motor driver. This is an IBT2H, I believe, rated for up to 40 amps. There are also smaller ones available. Those are L98N and they are rated up to 2 amps. You need some jumper wires to connect the ESP32 to the IBT. Then some cables just to power the ESP, to connect to the motor, and this is my battery, and this is the linear actuator. So to get a linear actuator it needs to be lock to lock for about 10 seconds. This one is, I don't know if the focus will work, but it's rated for 200 newtons and it will go in 50 millimeters per second, and the stroke is 300 meters per second. So in theory you get a 6 seconds lock to lock, but that's without a load. So how these work? There are a couple of wires, some position feedback wires, but the two thicket wires are the plus and minus. They can be red and black, that's normal. So to show you how they work, this is just to simulate my battery. I just like to use these very handy Wago clips. Just put them in there. Terminals are safe. It's probably also a good idea to buy a fuse. So how these work, or how a linear actuator works in general. Just if you add plus to the plus and minus to the minus. So I do plus and plus now. That's extended one way fully. So this is the end switch. So I have to do minus and minus. Minus and minus. And now if you just apply 12 volt current, so it starts to move at maximum speed. Control the speed you need a motor controller, because it makes a lot of sound on maximum speed. And if you just switch the wires, red and black, if you switch them, the unit retracts. Well, simple as that. I haven't told you, this is a ESP32 baseboard. Please mind how many pins it has. I think this mine has 32 free pins available. These little headers, I mean. The good thing about this board is, don't know if the focus will work. So basically, for each pin that the ESP connects to, you have a plus 3.3 volts, a ground, and the signal wire, which is a GPIO. You can just insert a DC plug type, and it's really convenient because you have a lot of pins and you can swap the boards. This one has an onboard, it says up to 16 volt conversion, and you also have some nice area to glue the ESP on. So I just slide it in here. Then let's start connecting. What to do first? Let's do the motor driver and the wiring. So black is always ground, that's a good one. So you need jumper, these are called jumper wires. They're both female to female. So I just pick a ground, G and D, ground, place it on pin 1 in this case, which is central ground. Will it focus? Will it focus? do these things focus? No. You have to believe me, it's in the top right. I'll make a better picture of it. So then again, these are the ground wires. Now the IBT2 has a plus voltage, plus 3.3 volts or 5 volts you can supply it with, and enable pins, and you enable them by apply the positive voltage to it. So I simply use some positive pins, so it's always has power. So it's located over there. So in my case, it doesn't matter which wire you take. This one is the VCC. Then this one is LEN, which stands for left enable. Okay, now the tricky wires is actually the signaling wire to turn either left or right at a certain speed using pulse width modulation, as you can see. So I use pin 33 to the left and 32 to the right. It's a bit arbitrary because you need the S line, the signal line, 32 and 33. So you can swap 32 and 33 because left and right is different for your boat. If you place the linear actuator on the right side of the boat and it extends, then you will steer to the right. But if you place this unit on the left side of the boat, you get a different angle. So just swap these if they're inverted. So I don't care which one. So let's put this one on RPWM, stands for right pulse width modulation. That one is now hooked up. I also prefer, if I now move to the power phase, undo this plug. So, got a neat little screwdriver. And on the bottom it says -1 of M minus, M plus, B plus and B minus. So B minus is battery minus and M stands for motor. So this will be the feed from my battery. So let's mimic that. These are 14 ABG wires, enough to hold 20 amp currents or so. So let's put this one in. Now just make a double check. We're now doing the battery, so this one is the battery minus. Battery minus. Okay, that one is in. I also bought silicon wires, and they're tint wires. So normally you see the red copper. These are tint wires. It's better in a salty environment regarding corrosion. Not a necessity. What I also got, please, I don't have one by hand, use an inline fuse, just a regular fuse holder for car fuses, and use a fuse that suits your actuator. So now hook up the linear actuator. You can use any motor that you want, as long as you've got a DC motor which runs on 12 volt. Normally you have a black and red wire coming out. This one is a little bit different. Actually the one on my boat is a hydraulic pump. a reversible hydraulic pump. I put this one in the motor minus and motor plus. And again, you can switch these around as well. So if your motor turns the wrong way, you can either switch M plus and M minus, or you can swap pin 33 and 32. This is a DC plug, the standard one, center positive, what is it, 9 millimeters thick, just to feed my ESP32. So I got my little Wago connectors here. Let's put it in. Let's put it in. I think we're all set. Plug it right in there. And then I have my battery connection left. I should have added a fuse. If you see smoke, I did something wrong. Perhaps it's a good idea to triple check. No sparks. So the ESP powers on alright, which is a good sign. Actually, this one isn't loaded by the Autopilot software yet, but I just like to check it. Always good. Why doesn't it work? Why doesn't it work? It's actually a good way to see. Signal 32 PVMs. Stupid me. This wire wasn't correctly attached. Always good. So when the Autopilot is off, you can move it manually. So this is cool, huh? So I can also turn it on, and now I can turn my phone to start moving. Okay. Awesome. So let's start with the programming of the ESP. So we need to do a few things. First of all, I still would like you to show how the wiring is. So this is the IBT2. From the main we have the battery connected, the motor, actuator, whatever. So from the plus 5 volts you go to the plus 5 volts and the two enable pins of the IBT2. Ground connection goes to the ground, and from pin 22 we go to the PWM left, and from pin 33 we go to the PWM right. Super easy. Now if you connect your ESP to the computer, you will have to hear a sound like bleep bleep. USB connected. If you open your device manager, you will see below COM port USB serial CH340, then it's okay. Otherwise you have to open the drivers and you download the Universal Windows driver. Okay, if that's correct, then you need to download the Arduino IDE. I already have it open here. I haven't installed it, uninstalled it for this application. So set it up, agree, only for me, only for me. Takes a little while. and even more while. So while it's installing, what you need to do is add the support for the ESP32. Arduino's default is a tool for Arduinos. So let's do finish. Go to tools, boards manager, then you type in ESP32, select the second one, ESP32 by Expressive Systems, install. It takes a while. Okay, successfully installed. So tools, go to boards, expressive. That's a way so we can see it's installed. Then you go to board, select another board and type. I type in dev kit. So do it ESP32 dev kit. Select it. COM6 serial USB port. That's correct. You can check your USB port by going to the device manager, ports, then you see your COM6, so that's correct. You can quickly, this is an empty sketch, so if you do file, new sketch, and you simply press this button and upload it, and see if it works. Just connecting and writing, resetting, done. Success. Here comes the tricky part. We have to create a folder named Autopilot Basic. So let's do that. Create a new folder. Call it Autopilot Basic. Go to the GitHub. Code. Download as zip. We can place it in my desktop. Autopilot. And so it's downloaded. Desktop Autopilot Basic. We can so extract all here. Sorry, that is in Dutch. Ooh, this is not what I intended. So all the files needs to be in this Autopilot main folder. Actually, the README is only a GitHub thing. The license, please read the license. So this is the sketch. If you double click the INO file, it will open the Arduino IDE. Select your board, it's the dev kit again, press OK. Then it's sent to the device. So it takes a while to compile because it's a bigger sketch. Doom, doom, doom. Takes a way longer while. Perhaps close this screen. It shouldn't matter. Oh, that's very busy.
So it's uploading. If it doesn't connect to your board, then you have to press and hold the EN button. If you see connecting, ... press and hold the EN button on your ESP32, and then once it continues, release the button. It could also be the boot button. There are many Chinese clones. There's also a way to work it. So it's done, and now to check if it's working, you go to Tools, go to Serial Monitor, and then you basically see everything that it prints out. Now you see serial begin 11th, that's the baud rate, technical term, doesn't matter. Select the same one in your serial monitor, and if I now quickly unplug and plug my ESP again, you see the setup complete. So basically what you see, so let's do a quick code safari, serial print line, serial setup complete. That's exactly what you see here. Waiting for a client to notify. That is about the Bluetooth connection. So let's start Autopilot app. You see it's connected immediately. Motor set to speed 0. If I, for example, now manually move the motor, then you see the received values. So then you know for sure that it is working. I don't expect you to adjust the code, but this is super simple. Well, simple is relative. This is all stuff could be deleted. So you set up the motor, set up the Bluetooth. That's all what's happening here. There's no loop. If you go to the Bluetooth file, you see some technicalities. So there is a clutch pin if you need a clutch for a hydraulic ram or something else. It's turned on. So what basically happens here, if you go to the setup, set the clutch pin low, initialize the device called Autopilot, make sure that all the over-the-air servers are created. It's very technical, but what you see here is actually the most important one. If whenever a command is received, it's a string, so we have to decode the little string. If the string starts with motor, then it's derive the speed from that string and set the motor to that specific speed. Okay, if you go to the motor.cpp file, you see the pins here defined for the right pulse width modulation 32, left 32, and right is 33. Set up that the pins are an output, move the motor to 0, and this is the setting the motor. So you have the speed and the direction. So there's still some old code in here. So defining the speed of the motor, and in the end, if the direction is 1, analog right, left PWM 0, right PWM is the motor speed, so it's actually turning right. And that's it.